This is the circuit diagram of fire detection with alarm sound using 8051 microcontroller. Here we have 8051 microcontroller. This is the power supply section. We use step-down transformer which will step down our 230 volt AC to 12 volt AC. After that we have a bridge rectifier. It converts AC to DC. Here we have a 470 microfarad capacitor acting as a filter here. After that we have a 7805 voltage regulator, output of which will plus 5 volt DC. After that we have a red LED for power indication in series with the 330 ohms resistor. Here we have a microcontroller with standard circuit, crystal circuit and the rest circuit. To the microcontroller, inputs are coming from the flame sensor, and the outputs are LCD, 16 by 12 LCD and buzzer. LCD will directly work from the program. Buzzer is controlled from the microcontroller through this NPN type transistor. The plus point of the buzzer connected to the plus 5 volt, negative is connected to the collector of the transistor, emitter is grounded, base goes to the microcontroller through this 2.2K resistor, and the microcontroller pin is pulled up with 1 kilo ohm resistor. So when a microcontroller delivers high logic, this transistor will conduct. The buzzer will sound. When the microcontroller gives low logic, that time this transistor will be open. Buzzer will be in off condition. Now comes to the flame sensor. In the flame sensor we have photodiode and 10K resistor making a potential divider, and variable resistor with comparator here, and output of the comparator is going to the microcontroller first pin. Let's see how the comparator works. In comparator it got non-inverting terminal, inverting terminal and output. This plus in non-inverting terminal and minus is inverting terminal. When plus voltage is more than minus, output will be high. When minus voltage is more than plus, output will be low. So our sensor photodiode sensing the flame, photodiode will detect the flame wavelength. So it is connected to the non-inverting terminal of the comparator. This photodiode, the beauty of the photodiode is, when it is connected in reverse bias, means the cathode of the photodiode goes to the plus and the anode goes to negative. Based on the light falling on it, its resistance value will change. When lights fall on this, it exhibits low resistance. When no light, it will exhibit high resistance. So based on that, this photodiode and 10K making a potential divider. Initially when there is no flame, it exhibits high resistance, so this point will be more voltage than this. So at the second pin we have a variable resistor to set the value, so initially output will be high. This is going to the microcontroller. So based on the microcontroller program, it will display no flame and the second pin will deliver low logic. The buzzer will be off condition. When flame brings near to the photodiode, it exhibits low resistance, so voltage drop at this point will be low, less than this, so output becomes low, so output goes to the microcontroller. So based on the program, LCD will display flame is sensed and the second pin will deliver high. This high goes and based the transistor, that time buzzer will sound.